The global energy system is undergoing a rapid and important transformation to decarbonise and electrify our societies. However, governments, regulators, system operators, and investors increasingly depend on quantitative models to design policies, guide investments and decisions, and operate a secure energy system. But many of these critical decisions and analyses still rely on proprietary software, closed data, and locked models, which decreases transparency and collaboration and increases costs and decision time. Thankfully, open energy modeling is a high-quality, transparent, and industry-ready alternative to proprietary energy models. And it is rapidly gaining momentum now as grid operators, energy companies, and large institutions are starting to use it more. So, what is open energy modeling? And what do we mean by open source and open data? When we talk about open energy modeling, the gold standard is that every single part of the process is open, from the raw data input all the way to the final insights. However, there are some contexts where it makes sense to relax this. For example, if data is commercially sensitive or private, or if interpretations cannot be shared publicly or is solely for internal purposes, or proprietary solvers are more performant than open source solvers. Let's break the open modeling process down then. What is open source? It is the term used for the software aspect of open modeling. To understand what it entails, we can think of the rights and 4 freedoms associated with free and open source licenses. These are the freedom to run the program or model, the freedom to study and access the source code, the freedom to redistribute copies, and the freedom to modify and redistribute modified copies. A common misconception is that free here doesn't mean no cost, it means free as in freedom. This is an important point, as free and open source software allows its users the freedom to use it for commercial purposes. So let's unpack the 4 freedoms and contextualize it for energy modeling. In order for an open source model to satisfy the first freedom, you must have the freedom to use it for your purposes, your projects, without necessarily needing to communicate this to the developer. The second freedom, being able to study and access the source code, is especially important to study the assumptions made in the energy model, how the data is retrieved and processed, and the limitations. This freedom is crucial for better transparency, reproducibility, and collaboration, as researchers, organizations, and the general public can inspect the modeling frameworks, influencing planning and decision-making. The third freedom is being able to redistribute copies of the model, meaning you can share it with anyone, anywhere, for a price or for free without asking for permission. Finally, the 4th freedom is the freedom to modify and redistribute modified versions of the models. For this freedom to be meaningful, access to the source code, freedom number 2, is an obvious requirement. With an open source model, you are thus free to make changes, add improvements, tailor the model to your region, and redistribute this modified version of the model. For example, there are many open energy modeling frameworks and workflows out there built by different people, institutions, or companies. The other important aspect of modeling is the data. So, let's explain what open data entails. In the fully open modeling process, data used would classify as open rather than closed. A widely accepted definition of open data is derived from the 2016 paper on FAIR principles. FAIR stands for findable, accessible, interoperable, and reusable. This means, for example, that data needs to be findable, each and every input file and assumption should be publicly available, and annotated or described by metadata. Accessible, data should be available in a non-proprietary format. Interoperable, a standardized language and formats must be machine readable and understandable for humans, and data should be reusable with different workflows or applications. Reusable, data must be released under a clear license with its provenance published alongside the data, explaining where the data comes from and how was it processed, when and how was it changed. Like open source software, open data also relies on licenses to enable effective reuse. So why does it matter for energy modeling to be open source? As we saw, the different freedoms allow users and developers clear rights, which improve transparency behind models, which increase trust in results as they can be examined and reproduced, if needed, as well as increasing potential collaboration as different actors can work and improve on the models. Digital autonomy and sovereignty are also key benefits, as models can be fully developed and run in-house or in collaborations without having to depend on external vendors with closed assumptions and opaque update cycles. Finally, anyone can use and build on top of open source software and models, reducing duplicated effort and funding. If you want to understand the differences between the modeling framework PIPESA and the modeling workflows PIPESA EUR and OpenTY NDP, feel free to check out our explainer video.